discuss this problem, which is product of binary decimals, which has recently appeared in Codeforces diff for round 937. So, okay, let's come to this problem. So, what is this problem saying? It is saying let's call a number a binary decimal if it is positive integer, okay, of and all the digits in its decimal notation are either 0 or 1, okay. So this is one kind of a binary decimal, whereas these are not, okay. So we are given a integer n. We are asked whether it can be represented as product of some binary decimals or not, okay. So there are test cases n, and we have to answer yes or no, okay. So let us see what kind of numbers are these binary decimals. So according to the question, the numbers which are having 0 or 1 as the only digits in the binary, not binary, no, in decimal notation, okay. So these are some this is binary decimals, okay. So 1 is a binary decimal, 1 0, 10 is a binary decimal, 11 is a binary decimal, again 100 is a binary decimal, 101 is a binary decimal number, 110, and so on. So in this problem, as you can see, n is up till 10 to the power 5. So there is no need to consider the binary decimals greater than 10 to the power 5, as in all these test cases the binary decimals are needed up till 10 to the power 5. So there is no sense to recompute all these binary decimals in each test case. So let us pre-compute all these binary decimal numbers up till 10 to the power 5. So we can directly write this vector by intuition also. These are just 1, 10, 11, 100, 101, 110. After this it will be 111, then 1000, 1001, then 1010, 1011, 1100, 1101, 1110, 1111. After that 1000, okay, and so on. So I guess there will be almost 32 or something. So how to compute these binary decimals inside a vector? We can see that there is a relation in all these binary decimals. Let's see this. 1, then 10. 10 is 10 times this number. Then 11 is 10 times this number plus 1. Then again 100 is 10 times 10. And this 101 is 10 times this plus 1. Then again this is multiplied by 10 to this 11, and so on. So we can see there is a pattern in all these binary decimal numbers. So we can compute the binary decimal numbers up till 10 to the power 5 using Q. How we can do this? So let's say we have Q data structure, where initially uh, we are putting 1. So we will use this algorithm inside Q up till like while the Q is not empty, we will be popping out the front element. If this element is less than 10 to the power 5, push this inside, not answer, that is binary decimal vector dot push this front element. And also after handling this front element, push this 10 times this front element and 10 times this front element plus 1. inside this queue, and this while loop will handle this thing and will create the vector which will be containing binary decimal numbers up till 10 to the power 5. So this will be taking almost how many of these are, wait, uh, there will be almost, I guess, 30, 40 something. So it will be big of one type, kind of operation to pre-compute all these binary decimal numbers. So now we have binary decimal vector which is containing these type of binary decimals, not one. I will be storing binary decimal numbers from 10 only, 10, 11, then 100, and this. It will be so on up till 10 to the power 5, right? So now we have this binary decimal vector. Now what we have to check is, we have to check whether this n is divisible by any of these binary decimal number. If it is divisible, then can we are we able to represent this n as product of some of these binary decimal numbers? There is no necessity for these binary decimal numbers to be distinct. Okay, so in this case we have to check for two things: that n can itself be binary decimal. Well, yes. So there are three cases. Let's say if n is equals to 1, yeah, it's directly yes. If itself is binary decimal, then yes. Otherwise, I have to check for its divisors, right? So let's say I am iterating inside this binary decimal numbers. If this number n is divisible by this binary decimal, then I will be again and again divide this n by this x to eliminate this factor. N% x is equals to 0. I will be dividing again and again n by x. Okay. At the end of this loop, I will be checking if n is getting converting to 1. Basically, if n is 1, that means we have already represented n as some factors. After dividing all the this n by all these binary decimal numbers which are divisible by which are dividing n, if n will be 1, that means we have already represented n as the product of these binary decimal numbers. So it will be condition for yes. Otherwise, answer will be no. So I guess now we are ready to go for coding part. So let's go for code of this problem. Yeah. So okay. So first of all, we are pre-computing this binary decimal number. So this is the vector which will be containing binary decimals up to 10 to the power 5. Okay, so yeah, we have used queue data structure. We can directly write this vector also. So initially we have post 1 inside the queue. We have popped the front element. I am checking whether front element is 1 or not, because I am not uh, as I have to check this divisibility condition here, so I don't need 1 inside my binary decimal vector. So I'm not pushing 1. I'm pushing all the binary decimal inside this vector except 1. Okay, and this is the uh, exit condition for this loop. If the front element is greater than 10 to the power 5 plus 5, just uh, just as bounds, so then I will be breaking this loop, so that I am by this condition I am making sure that this binary decimal vector will be will be containing only those binary decimals which are less than equal to 10 to the power 5 plus 5. Yeah, and yeah, again I am pushing this front into 10 and front into 10 plus 1 inside this queue. So there is a trick, or you can say good point in this implementation. I have I also have to check this case. this case, whether this n is itself a binary decimal or not. For that, I need to iterate from highest binary decimal to the lowest binary decimal. Because if I am iterating from lower binary decimal to the higher one, by this divisibility condition, I will be changing this n to smaller one. By this, I will not be able to directly check whether this original n was binary decimal or not. This can give me strong answer. So I have reversed this binary decimal number, like binary decimal vector, so that it is in decreasing order. So now let's go to this part where I am solving for each test case. I have initialized answer string as no initially. I am iterating in binary decimal vector. This x is instantaneous binary decimal. I am checking whether this binary decimal is dividing this n or not. If it is dividing, I am continuously dividing this n by x until it is getting 1. After all this iteration part, if n is getting 1, that means we are done and the answer will be yes. Otherwise, answer was no. So here I am printing this answer. So let's submit this code. Yeah, it's getting accepted. So thanks.